Good morning, Sevens. All right. So we had been talking on Tuesday, or you guys have been doing assignments around surface area. When I think of three-dimensional figures like this one on the right, surface area is like the wrapping paper that goes around the outside, like you're wrapping a present. But I had some things I wanted to connect with you guys just to make sure around volume. So I just made a quick video. Yeah, here we go. So area, I'd just like to connect it quickly to, it's basically the idea of counting unit squares. And we have more formal ways, way faster ways to count unit squares like formulas. But basically we're just counting up the amount of unit squares that goes inside of something, and that's what defines its area. So volume works the same way, but where area is two-dimensional, volume is now three-dimensional, and we're counting up the unit cubes that fill any sort of object. So if I had a three-dimensional object like this on the right, I can see cross sections of this. This 2x3 is this piece kind of on the front, we could think of it as. This 3x4 is the top, and it's also the bottom. If the 2x3 is the front, it's also the back. So we have these cross sections, and they have areas. This 2x3 is 6, this 3x4 is 12, so we can find those areas. But we can use those to find the volume of the entire thing if we think of one part as being the base. So if I call 3x4 being the base because it's the bottom and also the top of this, then 3x4 by 2, that gives us the volume of the entire thing. So it ends up being the base, so that 3x4, times the height, which is that 2. And it turns out for right objects, meaning that that corner right there, that the third dimension is vertical. As long as we have a base that's perfectly horizontal and then a height that's perfectly vertical, we have this generalizable formula, the area of the base times the height, which is really cool that it's generalizable for all right objects because it means we can do all kinds of different things. These are very different types of three-dimensional objects. Over here we have a prism, a rectangular prism. You think of it as a rectangle that has height to it. It's like a box. And on the right we have a cylinder. Well, on the left, the base here is a rectangle. It's 10 by 4 because its base times height is the area of a rectangle. So I get that area of that base, and if I multiply by the height of 5, we get the volume of the whole thing. The cool thing is that the exact same process works for a cylinder, where the base is a totally different object. It is a circle. We have a totally different type of formula for it. I can approximate pi with 3.14. The radius here is 3, and so then I have an area for the base of this object as this, and if I take the area of the base and I multiply it by the height, in this case 8, multiply those things, I get the volume of the entire thing. So in general, in order to find any volume where you have a right angle, like a horizontal base with a perpendicular height or a vertical height, you can always do the area of the base times the height. The last thing that you need to know, these I know are super fuzzy, but you just have to have the idea that any other objects we'll deal with, you can just cut them apart into fundamental objects. And I think it's pretty clear with the idea of what you see here. We have to take these objects on the left and make them into something like the object on the right in our heads. So when I think of something like that, I might cut this object over here, right there, kind of, and I think of it as this prism on the bottom and then this prism on the top. So I know for each of those, the volume is the length times width times height, or base times height times depth, or however you want to think of it. So then if I think of this chunk down here, I would get that, oh, and I covered up the pieces. I would get that 3 times 2 times 14 for this chunk down here, and for this chunk up here, I would have to know if this is 3 and this is 12, then this piece here is 9. And if this is 14 and this is 9, this piece here is 5. And you just find those dimensions and then multiply them together. And this depth hasn't changed. So I think in both cases that is 2. And if I multiply those pieces together and I would add those, you'd have the volume of the whole thing. And that's the last piece that you have to know about volume as a 7th grader. It's just that we have composite pieces that always come down to the area of the base times the height. And that's all I'm thinking of when I do this, is like that's the base times the height of the thing. That's all I had to share with you today, Sevens. So best of luck, and I will talk to you soon. Bye-bye.